Hello developer, how are you doing today? Welcome back to the part 3 of React interview question series. I hope you have enjoyed last two parts as well. Today's part is very important because we're getting into some topics which are very frequently asked in an interview. And this is for the folks who are little above the beginner level, people who are probably coming for an interviews which is like 3 to 5 years experience kind of thing for web development or a React based interview. This portion is pretty important for them to understand these concepts. So part 3 and part 4 both will be for folks who are like intermediate to advanced level. But if you are a beginner, I would suggest that first you complete part 1 and part 2 and then come to part 3 because you will have a continuation of it. So what are we going to cover today in part 3? So let us see like what we're going to cover. So in part 3, we are going to cover about React hooks. We are going to cover about context APIs. We are also going to talk about performance. So these topics are very important for you to crack interviews. These topics are very important for you to build apps. So one suggestion I'll give, like as and when you are learning this topic from this video, make sure you take good notes and then you start building things, start practicing things. That's pretty important, right? So learning alone, just going through this video is not enough. Practice is more important. All right, so without any further delay, let us get started with part 3 of the video, part 3 of this series. Thank you. So the first question now is, what are hooks? What are the rules of hooks? Okay. And while answering this question, what we'll do is like we'll cover like what are hooks, why React needs something called hooks and how exactly it works. What are the most common hooks, that are available? And then we will talk through some of the rules of the hooks, right? So let's get started. Now to answer the question like what are hooks, I want to get into lot of fundamentals, right? So to understand React hooks, one should understand very clearly the concept of JavaScript functions. Yes, plain old JavaScript functions. So if you have a JavaScript function, like some function, the function can have one more function nested in it, right? JavaScript allows it. Now you can have another function nested in it, JavaScript allows it. So it means a function can have a function and another function also can have a function in the hierarchy fashion, right? This is allowed in JavaScript. Now, similar way, in ReactJS, the components are nothing but plain old JavaScript function with respect to the functional components, right? In this entire series, we are not talking about the class components at all. We are talking about only functional components. So in functional components way, the React components are nothing but plain old JavaScript functions, right? We know that, we have learned that. So as the functions can have one or more functions in it, a component can have multiple components in it, right? With the logic, because components are nothing but plain old functions. So it means that the component can have multiple components in it as a composite fashion. Like a component A is a composition of component B and component C. That's what we are saying over here. Okay, great. So let's move on to the next one. Now, when we actually write a component, what we need to keep in mind is like the component should be as much as stateless possible. What exactly stateless mean? It's mean that whatever the things that we are writing in a component, whatever the business logic that we are writing in the component, are there opportunities for me to take out those business logic elsewhere? Because if tomorrow there is a chance of reusing that business logic elsewhere in another component, I really don't have to, write it again in another component or tweak this component at this point of time to break it into multiple things. I don't have to really do all this circus at that point of time. So better I make my component as much as stateless possible so that all my state management, all these side effects, everything happen and everything, taken care separately than my component. My component is as lean as possible. And of course, my component is, in a way like for same input, it always provide the similar output, means the component should be a pure component, right? That's what I would like to focus on. Now to do that, the stateful logic has to go somewhere. Where exactly the stateful logic has to go? Of course, the stateful logic, if you want to take out of a stateless component, the things that it will depend on is the stateful logic is something which is reusable. Is this making my component really bloated? Or is it making my component impure? In those cases, I'll be trying to taking out the stateful logic out of this component. Now, how can we do this? We'll talk about stateless component. So a component stateless component side effect less, if I want to make it, it means that there are very daily operations that I can actually manage in a component, like logging to console, making an API call, fetching data from the server. All these kind of things I have to manage somewhere, right? One by one. That's what I have to do. Like my stateful logic goes out of stateless component, stateful logic goes out of stateless, stateful logic goes out of stateless component, and those logic as a method of composition we can use in the stateless component. Similarly to the function thing that we have seen, a function can have multiple functions in it, like components can have multiple components in it. My component is nothing but a plain JavaScript function, so it can actually get the multiple such things, inside the component. Now how can we achieve this? This is where the hooks come into picture. This is where React provides you something called hook, where you can actually take out some of this repetitive work that you want to share across multiple components. You're managing the side effects so that you can make your component as pure as possible, as stateless possible. That's where the React hooks come into picture. Now imagine a component where the data fetching logic is separated out, the logging into the console logic is separated out, maybe a search and filtering logic is separated out. Now, if you think, just notice little bit, the data fetching, logging, search and filter, all these things are nothing but quite reusable thing, right? How do you want to fetch data from the server? Maybe just the URL that gets changed, but the method of fetching is remain same. How are you going to log into a console? Maybe the only message and the log type gets changed, but the way of logging is going to be same. How do you search and filter? Maybe the list where you are searching and filtering gets changed, but the methodology for searching and filtering remains same, right? So these things are the candidates that you don't want to keep it in your component, rather want to take it out elsewhere, which you can actually reuse multiple places for the multiple component. That's where React hook comes into picture. So here is a example, like you have three components, component A, component B, component C. Now I may have a React hook which is doing data fetching. The same React hook I can use for component B, which is like again data fetching. For component C, I may be using a completely different React hook, which is like just doing the logging, right? It's possible. So this is how things work, and this block you keep in your mind, so you can actually answer like why React hook is important and how hooks play its role. So in React hook are simple functions that we can use to separate out the reusable part from a functional components. It can be stateful and it can manage the side effects. Now there are varieties of standard hooks possible. There are varieties of hooks that React provide out of the box. We are going to talk about them a bit, and then also we are going to talk about what are the rules of hooks, and we are going to see a hook quickly to identify, oh, this is a hook that we are talking about. Okay, so let's do that. So let's talk about the standard hooks. Standard hooks are the React hooks that comes out of the box, and because if you're using ReactJS, these hooks are available for us to make use of it, right? So this is the list of, as of now, the list of standard hooks that are available. For example, useState is managed to manage your state. Returns a stateful value and an updated function to update your state. That's what useState is about. UseEffect is to manage the side effects, like API calls, subscription, timers, mutations, etc. UseContext that return the current value of a context. We will discuss context a little bit more in the upcoming question. UseReducer is something which is like an use state alternative to help with complex state management. That is what UseReducer is about. useCallback, it returns a memorized version of a callback function to help your child component not to re-render unnecessarily, right? That is useCallback. And then it has another counterpart called useMemo, again for the memorization. These two things also we are going to discuss in depth in the upcoming question. useRef we have discussed in the previous parts of this series. We know that like it returns a ref object with a .current property. The ref object is mutable. It is mainly used to access child components imperatively. We know that. Then we have few things like use layout effect, use debug value, not so frequently used hooks, but good to know that layout effect is something which fires at the end of all the DOM mutations. it is best to use use effect as much as possible instead of use layout effects, basically, because use layout effect fires synchronously, and we don't want that in your application, And then use debug value is like an helper hook, I'll say, which display or label in React Dev Tools for any, for the custom hooks for a debugging purpose. Now, these are the standard hooks were available before React 18. Since React 18, we have 5 more brand new hooks, which is like use transition, use default value, use ID, use sync external store, and insertion effect. So let's talk about them a little bit. Use transition is a hook for transitions, as the name suggests. It returns a transitioning state and a functions to start the UI transition. So whenever React state updates, it actually classified between 2 different stages or the categories. One is what is like urgent update that we have to do now only, and another is transition update, right? So these 2 things, how will you manage? That's where use transition hook come into picture. We have a question coming up for use transition to get deeper with that. Then you have use default value is another hook, which is also useful to accept a value and return a new copy of the value, which will defer to more urgent updates. Like, so when you talk about use transition, we'll also touch base of use default value. Use ID, as the name suggests, like your application, there are cases where you need unique IDs. In that case, you can use IDs. Use sync external store is basically a hook that is for reading and subscribing from the external data store kind of thing, and then have use insertion effect for external libraries to kind of use that particular hook. So these are the standard hooks that are available that you can make use of. Let's talk about the rules of hooks. What are the rules? There are basically 3 rules. These 3 rules that you have to keep in mind. Whenever you're using hooks, only call hooks at the top level. Don't call them inside any loops, any nested function, inside a condition like if and else, because putting it at the top level will ensure to preserve the state correctly. When the multiple renders happen, basically when there are multiple time use state or use effect calls get called, the state value will be preserved correctly. But if you put it inside the if and else based on the conditions, it might go wrong. So that's the reason there is a rule that only use the hook at the top level. And then the second thing is like, don't call it from a regular JavaScript function. So hooks are though JavaScript function. We told that those are like plain old JavaScript function, but those are specially available only in React. So these are like React enable JavaScript function that you can think about it. So you can call them from a components, but don't call them from any other JavaScript functions, plain JavaScript function. You can call them from either components or from any other custom hooks. Now, what is custom hook? A custom hook is something that where you write your own logic. Just now we have seen that bunch of hooks that come from React, but apart from that, you should be able to write your own hook as well. In that particular time, you can write your own logic. You can extract the component logic into a reusable function. You can share it across components. That's when you'll be writing the custom hooks. And when you write a custom hooks, make sure that you start with the word use, because this is the way in your code base you can identify, oh, this is a hook versus that, any other regular JavaScript file. Like an example is like use storage. This may be a hook which is dealing with some kind of storage operation. So you have named it as use storage. So these are the rule of hooks. So that goes our first question of the part 1. It was like little elaborative, but it is good to know and good to kind of set the stage for this one. Now let's get to the second question. The next question we have is about use callback and use memo. So the question in an interview might come like, what are use callback and use memo? So when an interviewer asking this question, the main intention behind that is to know like how much of you appreciate the ReactJS performance optimization and where exactly use callback, use memo come into picture, when to use them and when not to use them. So let's go through these particular question answers and try to figure it out like, how to kind of proceed about explaining it. Before we explain use callback or use memo, we have to get accustomed with a term called memoization. So it's not memorization, it's memoization. Okay, the R is missing. So this is a technique that we want to understand. So let's understand this technique well. For that, let's assume that we have a function. The function name is expensive function, which takes 2 parameters, m and n. What exactly this function does? It takes like these 2 arguments and based on these two arguments is try to compute something, but the computation may take a longer time, and that's why this function is called expensive function. Now it has two arguments, like we are passing m equals to 2, n equals to 3. So based on these two arguments, it is going to calculate and figure out like, okay, what is the output of this expensive function. Now, as long as that m equals to 2 and n equals to 3 is same, the expensive function is going to produce the same output, right? So if we can do something like, as long as there is no change in the argument value, we can actually make the function return the same output for the same input. So we get the memoized value and return that. Memoized value means it's like a cached value. It is not, the expensive function is not going to compute it all over again from the beginning. So it's like cached value, that's what we are interested in, right? If the input change for the different input, again recompute and then memorize the value and then return. It means that you do a computation again, then store it in the cache and then again return. So that next time onwards, again if the same pattern exists, like same kind of input coming, you are taking from the cache and returning. So this is something which is like work out very well for expensive function if you are going for a memoization. Now we know that in React, basically the components are nothing but plain old JavaScript function, but it has certain sense of React. We have actually gone through it in our past question answer thing. So now can you visualize that this expensive function can be a component as well? Okay, let's see that. But before that, the memoized value is called a memo. This is a term that you need to know. So you might be hearing like a lot about, memo, useMemo, react.memo, all these things in React. But when somebody calls the term memo, it means the cached value or the memoized value. Okay, so that's something that we have to keep in mind. Now let's take this. Instead of the function, it is now a React component. Expensive component is a React component, and instead of the parameters, the arguments that m and n we saw, now it is like two props, right? So for a component, the inputs are mostly like props, like the props that we pass, and based on that, the component reacts. So we have two props, m and n. Okay, so as long as the props values are same, the component actually can return the same output. In terms of components output is the JSX, right? So the component can return the same memoized cached JSX. If the input changes for a different kind of props, it actually recompute the JSX, memorize the JSX and then return. So whatever we just learned for the function, same thing that we can actually extrapolate for a component in case of React. Okay, so that means the function memorization, that whatever we learn exactly can be used for ReactJS component. Now what is memoization? Memoization is a technique to optimize computer programs by caching the results of expensive function calls and returning for the same input. If we tell it in the React sense, then memoization in React is a technique to optimize the program by caching the JSX results of expensive component operation, returning it for the same props, right? So that's the only difference between these two. All right, so next, what is useCallback and useMemo? So useCallback and useMemo are two standard hooks, React hooks, that exactly exist for the purpose of memoization. So it means that if there are same input available, don't really recompute any expensive thing, rather return it from the cache. So there are two variations of this available. One is called useCallback. We'll talk about that first, and then useMemo. What useCallback does is like, useCallback returns a function. It returns a function as for the same function, basically, as long as the dependency that you pass in the useCallback is not changing. So if you remember the signature of useEffect, it used to take a callback function and then the dependency array. Exactly same like with useCallback, where it takes a callback function and a dependency array. The first argument is the callback function, second is the dependency array. So in the dependency array, whatever you pass, like depending on this particular dependent factor, my callback function output should change. If the dependency array is not changing, useCallback going to return you the same reference of the function all the time. So it is like cached. So it means that it is not going to do any kind of new computation. It is not going to kind of create something new for you. It's going to give you the same function every time you call for the same dependency array. And once you get this function, now you can actually call this, invoke this function. You know, if you get an fn as a function, you can do fn parenthesis. That will be the invocation of the function, and you will get the result. If the dependency array changes, but its value changes, it means useCallback will not return the same old instance of the function. Rather, it will send you the fresh new instance of the function. And again, if you call that function like fn parenthesis, you will get the new value. So this is how the memoization work with useCallback. Now there is another variation called useMemo. The only difference between useCallback and useMemo is useCallback return the function for you that you have to execute. useMemo actually execute the function for you and return the value. So it executes the function and return the value when this guy changed, the dependency array change. So exactly the same thing. This return the function that you have to invoke. This actually invoke the function and return the value. So based on your use cases, you can go ahead and learn. So whenever an interviewer asking the question about useCallback and useMemo, always start with talking about the performance optimization, caching, memoization, and then tell like this is the purpose of why useCallback and useMemo have been used, and this is the difference between useCallback and useMemo. Now the last thing about this question, should you use this useCallback and useMemo always because it really takes care of memory optimization? No, you should not, because think about a case. React in the background actually running a check that whether the dependency array has got changed. If the dependency array has got changed, then you recompute. If it has not changed, then you return the cache value. This is kind of a switch statement or if else statement. Something is running at the background. You don't want this extra thing to run all the time, right? You don't want that to happen all the time. Rather, whenever you clearly know there is an expensive operation going to happen inside your component, only on that cases you use the memoization. Only on those cases you use callback and useMemo. If you know that this is like simple function, it's not like really expensive, it is not going to take really lot of CPU, lot of memory, or lot of time complexity, then just don't use callback, useMemo. Go as usual. But if there is those things come into picture, please go ahead with use callback and useMemo. So that the bottom line is be really cognizant about when you have to use callback, when you have to use useMemo, and whether you have to use at all or not. I hope that this is clarified now. Let's move on to our next question, where we are going to talk about context API. Alright, so the next question that we want to take up is about context API, and the question is like, what is context API and how does it work? When an interviewer asks a question like this, the intention basically to understand like what is your thought about using the context API in the ReactJS application, because there are a bunch of alternatives available of context API. Then why do you need it actually? So it is not about telling like the context API exists and how to use it. It's also about talking about like what is the real use case of it. So let's explore that. So in ReactJS we have things called context, and the context in general is something like a bunch of information that you want to keep and share in your application. So one context could be user context, another context could be theme context, another context could be maybe some kind of storage context. So it means that in that particular context, that related data will be stored and the related data can be retrieved and used, right? So let's understand the concept of context with this particular use case. Is called the family secret. Now, let's assume that there is a family, the Smith's family is having a family secret. That secret should pass from the family parent to children to grandson to granddaughter, things like that. Now, if I put forward this thing in front of you and tell like, how do you pass this family secret from parent to children to their grandchildren? I'm sure that you will be telling that props is the way that we can actually pass it, which is actually correct. Through props, you can actually pass this. Now, think about an application where the things are very much hierarchical. It's like there are a lot of hierarchies available, and then passing something from the top of the root till the bottom of the tree is like is something like it's not so manageable, and also like it is hard for you to debug. Like if you just keep passing the props from the top root till the bottom leaf, and there are too much into the hierarchy, like how and when these props getting changed, what is getting passed. So instead of that, also I should not forget this, also is like something that you might want to pass which is not in the direct hierarchy, right? The props can be only passed in the direct hierarchy, but sometimes you might want to pass something which is not in the direct hierarchy. Then in that case, the props may not work well. So and then lifting the state up from the child to parent, all these things that you can actually avoid using the context. So let's understand with the family secret. So the first thing is like family has a secret. This is a family secret. Now the how we want to pass it is like I want to pass it to parent, from the children, from the grandson to the granddaughter, and none of these things are getting passed through props. Rather, these things are getting passed through something called context. So let us kind of understand like what exactly the context, and we'll be also looking into some of the code for it. So the context are something which is like information that is globally available. You determine the hierarchy, whether you want to make this information available into the full hierarchy of the application or in the partial hierarchy of the application. That is up to you. For example, if I'm talking about theme, like dark theme, light theme, this particular context should be available into the entire hierarchy of the application. But if I just talk about, let's say, some kind of salary data, that particular context may not be required to be available into the entire application, but maybe where we are talking about employee, the components which deal with employee, there only the salary context is required, right? So depending on the use case, we can actually make it available. There will be a context provider. So whenever we're talking about context, there are two things. One is like provider, another is consumer. A provider which actually provide the information to the context, a consumer which retrieve the information from the context and use. So there is always a provider and a consumer. So there will be context provider. All the children, okay, that are supposed to get the information must be wrapped inside this provider. So this is something as a rule that we have to remember. So all the children that are supposed to use this context must be wrapped inside a provider. We are going to see the code in a minute. And then every consumer can extract information using the hook called useContext. So this is another hook which is provided by ReactJS out of the box. So every consumer can extract the information using the useContext hook. There can be multiple contexts in an application. So we spoke about it, that there can be multiple applications like, theme, user, salary, whatever you want based on your use cases. Here goes an example where we have a provider and there are consumer. This might be a like theme provider. There is another provider and there is a consumer. This can be a user context and things like that, right? So there can be multiple provider and consumer. Now let's look into this family secret app code and try to understand how do we create context, how provider pass the context, how the children get the context. Let's look into the code right now. React provides an API called createContext to create the context. Now every time you call react.createContext, you actually create a new context. And that context you can give a name based on whatever the use case that you are dealing with. For us, we want to create a context for the family. So we have created a family context using react.createContext API. It is good to keep all this context, created context in a separate file and then import it wherever you require, than kind of putting it inside the components and things like that. So separate out the context. You might want to just create one context.js file and having multiple contexts created in that file and then export all of them and then import wherever it is required. So it's up to you how you want to handle it. Now we have this family context created. Now I told that whenever there is a context, there is a provider and there is a consumer. So provider is something which will provide the value to the context. Consumers will take this value on demand whenever required. And all the consumers that want to consume this context should be wrapped inside a provider. Now for this particular application, I want this family context to be available in the entire tree of the application, entire hierarchy of the application. So that means the provider that I want to put it at the top level, as much as top level possible. That's why I have put the provider in the app.js function. So if you see, I have family context dot provider, and family context dot provider has an attribute called value. Through this, you provide any value to this context. Now the value that I'm providing over here, it can be an object, can be a string, can be a number, can be any data type. Whatever value you provide, all the children of this context, like in this case family, and inside family if there are other hierarchies, every component having access to this particular family secret. All right. So what is family secret for me? It's a simple JSON, like an object. which is it's an object. It's like simple object. I would say having family name, a function called only parent can see, only grandchild should know. Right? Simple thing. And I've always imported the family context. Now context is set, provider is set. Now if I go inside family and then see, I have created a hierarchy. And by the way, one thing notice, I have not passed any props. I have not passed this one as a props. I am passing this as a provider. So if I go inside this, there is no props. There is another hierarchy called parent. If I go inside this, again there is no props, but I am importing the family context and I am using the hook called useContext to retrieve the information that is provided by the context provider. And in this one, I'll have the exact same information that I have passed over here. The family name, only parent can see, only grandchild can see. So over here, what I'm doing, I'm extracting the family name and putting in my JSX. Only parent can see, I'm extracting and putting over here. Again, parent is having a children, and again I'm not passing any props. If I go to children, I can again retrieve the secret and put like family name. Okay. Again, there is a grandson and granddaughter. I'm again not passing any props. If I go to grandson, I am saying like only grandchildren should know method from the secret. So this is how you can actually distribute your information either throughout the hierarchy or partially in the hierarchy without passing the props explicitly. So another alternative is definitely of context is props, but we told that where props may not work. There is another alternative to do it is like using the centralized store with the Redux kind of methodology. We'll be learning that in a while. So I hope this use context thing is exactly clear to you. The next thing that we're going to talk about, another exciting performance fact, and let's see like how that works out. So how was it? Did you learn something new? I hope you did. So if you have learned something new, please make sure you like this video, and also if you have any queries, post a comment in this video. Practice is the main thing. Just looking to the video is not enough. So if you practice and build something with the concept that you learned today, please make sure that you comment that in this video. All right, so we'll be coming back with part 4 very soon, where we'll be learning about app responsiveness and many other exciting topics. Until then, take a great care of yourself, and I'll be back soon. Thank you.